Okay, so you are looking at polar graphs. Now, you guys have graphed points many, many times. But what have you graphed? You have graphed this right here, right? This is called the rectangular graph, the rectangle, or the Cartesian plane. This is x comma y, right? So x, here, watch. 5 comma 10. Over 5, up 10, point. Over 5, up 10, point. This is the same thing, except it's not going to be x comma y. It's not x, y. Boom, boom, get rid of that. It's now this. There. That's what you're graphing. R comma theta. What's R?
Radius.
Radius. What's theta? Your angle. Okay. 20 degrees, 50 degrees, or radians. I could say 2/3 pi. I could say whatever. But basically, you will go this far, radius, and then you'll just go around the circle, and wherever you stop, boom, you put a point. That's all it is. Now, just a quick note about your graph paper. I can't see very well up here. I see the red lines, but I don't see blue. But I think you guys have a line here, a line there, and then this line, what does that look like to you? When it comes to degrees, this one. 45. That looks like 45. So it's really just pi over 4 or 45. Okay? What about this one? Right here. 30. What's 30?
Pi over 6.
Yes, pi over 6. 30 degrees. Good. Now see, here's why I wanted to talk to you. What's this one? It's half of 30. It's 15. But what's 15 degrees? If this is pi over 4, pi over 6, what's this? Yeah, how many of these are in half a circle? Remember, half a circle is just pi, right? So all the way over here is pi. So this is broken into 12 parts. So when you go around the circle, you have to know you're counting by 1/12 pi, 2/12 pi, 3/12 pi. And of course, they reduce them to get these numbers. Pi over 6, pi over 4. What's the next one right here? Pi over 3. Or 60, right? Guys, this is just a refresher of chapter 4. We've done all this stuff, okay? Okay, next slide. Here we go. Oh, here it is. Okay. Now, in the polar graph paper, you guys remember the origin is where the two axes, x and y, met? Well, when it comes to polar graphs, the center of the circle is known as the pole. Think of the pole as the origin. It's the starting point. Where do I start graphing from? The pole. And then think of the polar axis as really just, what do you think? What do you think of that? I think of that as kind of like the x-axis. So that's kind of how I think about it. The pole is the origin, and the polar axis is the x-axis. Okay, and this ray that you see going this way, this is called the initial ray. So to me, everything starts on this axis. And then it goes around and around and around. Okay. Now, here's what I'm going to ask you to do. Can you estimate this point? R comma theta. We're going to estimate this. Okay. Well, first of all, from here, I call this point O. To here, call this your point P. How far is the radius? How far is that? Well, you could sit there and count. Or you could just kind of eyeball it back to the polar axis and then start counting from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you think it looks like? What do you think I'm at? I mean, don't look at mine. Don't look at mine. Look at yours. You can see yours so much better.
Looks like it's a little over like 8.
You think it's over 8? Okay, I do too. I think it's like 8 point what? 1, 2? I'll put 2. Nobody said anything. 8.2, comma. Now what's next? I need the rotation. I went from here, the polar axis, all the way up to here. Now again, this is you estimating. Take a look at your graph paper. How far do you think I went?
Like 63.
63?
64.
64. Okay, period 5 and 4 said 67 and 68. Is that about, you guys, I don't know, getting some strange looks right now. Okay, so now, can I go with that one? Will that make you happy? I don't really care. I just wanted you to say somewhere between 60 and 70. I'm just telling you, period 4 and 5, they said 67, 68. Okay, are you okay with that answer? It's well past 60, isn't it? Yeah. Okay. Good enough. All right, let's do it again. Get me that point right there. Get me R, get me theta, estimate the best you can. This would be R, just so you know. That's your radius right there. How far up did I go? Kayla, did you come up with a number or not?
10 for the first one.
She thinks it's 10. Are you guys okay with 10? You going like this? You okay?
Yeah.
Some period 4 and 5 each said the same one. 9.9.
Yep.
Okay, is it short of 10?
Yeah.
Just by a hair, right? Sorry, Kayla. You know what, Kayla? You and I are the same. I just wrote 10. Because I just said, looks like 10. Okay, how about theta? How far did it, okay, how far did I rotate around?
It's like a little over 150.
So what,
151, I guess.
Yeah, period 1, or period 4 said 151, period 5 said 152. We're right on. Good job. You okay with this? That is polar coordinates right there. R comma theta. That's that circle back there. That's polar, and that is rectangular. X comma y, R comma theta. All right, here we go. Plot the point. 4 comma. Oh, sorry. Ugh, forgot to tell you something. There is a definition in your book what R is, what theta is. I don't really think you have to write this down, but if you want to, because you just like to know the definition, this is the book's definition. Theta is the directed angle counter clockwise from the polar axis. Axis to segment OP. See, I sometimes you listen to these things, you go, what? Okay, all theta is just an angle. It's a directed angle. What do you mean by directed? If I give you a positive angle, which way are we going? Guys, which way did I go every time? Positive is this way, counterclockwise. Okay, from where? The polar axis to where? Segment OP. Well, where's segment OP? Segment OP is right here. There. What they're saying is start at the x-axis, go this direction till you hit OP. There. That's theta. That's all you care about. Now, what's R? You already know. What's R? It's your radius, right? Okay. But in the book, they call R, the radius, a directed distance from where? O to P. So from O to what? P is the radius. See, I think you knew that anyways. So I'm not sure if you had to write that down. All right. Next slide, I want you to graph that. And the next slide, graph another point. So it's really the same thing twice in a row. First graph 4 comma negative 3/4 pi. Then look at the next slide. It says graph another one. How about if I give you 30 seconds just to graph that one? 4 comma negative 3/4 pi. Now if I were you, I'd go 4, that's the radius, start at the pole, go out 4, then you got to look at the angle was negative. Which way am I going to go now? Clockwise. Okay, I got to go clockwise that far. Well, that far, first of all, what is this right here? That's just a 45, right? So how many 45s do I have to go? 3 of them. So here's me going, okay, well, there's 1 45, 2 45s, 3 45s, I'm right here. Would you agree with that?
Mm-hmm.
Okay. Or you could say, isn't that just 135 degrees? If you want to convert to the number, go ahead. But I think you guys, if I know I have to go 45 3 times, it's just 45, 45, 45, there I am. That's it, right there. That's the point. Okay, the next slide says do it again, but caution, careful, when R is less than 0, by the way, less than 0 just means when R is negative, we go what? R units in the opposite direction, and then we graph it. Okay, so plot this point, negative 2, comma, 2/3 pi. Go plot it on the previous slide.
I like the polar bears on there.
You like the polar bears? Just gives you that cold feeling. We should be doing this lesson in December, shouldn't we? All right, where'd you go? Hey, where'd you start? Where do you start?
In the center.
Okay, the pole. I was hoping you'd say the pole. Start at the pole, go where? Left 2, there's 1, there's 2, there's 3, there's 4. So left 2 right here. Then you got to go this right here. By the way, what is pi over 3? 60. Go how many 60s? 2 of them, so that's 120. So which way am I going? This way or this way?
Up.
This is a positive direction. Positive directions for angles are which way? Counterclockwise or clockwise? Counter. So if it's counter this way, and you're starting right here, this is where you're at, you're already back to positive 120 would get you, can't even see where I'm at, I think it's about right here. I think that's it right there. Negative 2, comma, 2/3 pi. There it is. You don't need this piece, so get rid of that. There it is. That's actually the answer right there. It's just a point. Is that where you put it? Because if you went this way, if you went 120 that way, landed here, you don't have it. That's not right. Okay, good? Okay, next slide. Not this one, this one. Okay. You guys remember coterminal angles? Do you guys remember coterminal? Remember this? 30 degrees is the same as, give me another angle. That would mean 30. That would look just like 30. 390. Hey guys, you can do the same thing with polar coordinates. You can get right back to that same point with a different ordered pair. So what I'm saying to you is this. If I were to give you this point right here in polar coordinates, 3 comma, oh, I don't want to do 45. I want to do 60. 3 comma 60 is right here. 1, 2, 3, up 6. There it is, right there. That's the 3 comma 60. A single point can be named infinitely many coordinates. Can be named by infinitely many coordinates. So give me another set of coordinates that means exactly that point, Frankie. Looks like your hand's up.
No. 3, 420.
How'd you get it?
I added 360 to 60 degrees.
Right, so here's what she does. She says, if I want that same point, but a different ordered pair, she takes her angle and she just adds 360. So to get from there to there, it's just 60 plus 360. And she's right, that is another ordered pair. Now what if I talk about radians, not degrees? If I talk radians, what do we do now? If I go like this, 3 comma, let's go pi over 2. How do I get another one?
Add 2 pi.
Add 2 pi. Yeah, just add 2 pi. So if you add 2 pi, pi over 2 plus 2 pi, well, 2 pi when we talk about halves is 4 halves pi. So what's the answer, guys? Yeah, 5 halves pi. That's the answer. So what if I want another one? What do? Add another 2 pi. So really what it is add 2 pi, add 4 pi, add 6 pi, add 8 pi. Just add what?
2 pi.
Even pi's. Just add even pi's. 2 pi, 4 pi, 6 pi, 8 pi. Just do that and you get the answer every time. Okay, so here comes your problem. Ready? What are coordinates of the point shared with this? Given that you keep r greater than 0. If you keep r greater than 0, that means this 3 has to stay 3. 3 can't change because it's already positive, right? Okay, so what will it be? Well, you already know you're here. 3 comma pi over 4, which is about here. That's 3 comma pi over 4. So what's the next answer? Give me another version of that answer.
9 pi over 4.
9 pi over 4. How'd you get it?
Add 2 pi.
So you added 2 pi. She took pi over 4. She adds 2 pi, which is that. Did she get it right? Sure she did. That's right. Good job, Olivia. Easy. At least I think it's easy. If you wanted another point, keep it 3, 3, 3. What would you do now? One circle, that's what Olivia did. But can I do 2 circles and get to that same point? Add 2 pi again, yeah. So add another 8 fourths pi onto this. You'd get what?
17 fourths pi.
Yeah. See, there are so many. How many? Infinite. You can go forever on this. Okay, so the rule of thumb. Here's the rule of thumb, just so you know. Hang on, let me get rid of some of these. So if you ever want an answer to this, all you got to do is this. Keep your r the same. If they give you 3, put 3. What would you do to the original angle? Just add 2 pi. That's all you have to do. That's what Olivia did. And by the way, the book will tell you not just 2 pi, but 2 pi n. Why? Why 2 pi n?
You can just keep adding 2 pi.
Right. So if you put the number 1 in, that's 2 pi. If you put 2 in, what is it? 4 pi. 3, 6 pi. Just keep adding even. Okay. Whoa, I don't know what I was doing there. Just put in integers. Okay. That's all you do. Okay. Now, let's do this one. What does this one say? R is what? Less than 0. So change your R value from 3 to what?
Negative 3.
-3. Gotcha. Now what do I do to this angle that they gave me? What do I do to that? Subtract 2 pi. Okay, hang on. You guys, that's not right. Don't do that, but I want to show you what's happening. What was the original point? 1, 2, 3, up 45. About here. This is 3 comma pi over 4. Look what they're asking you for. They want your R value to be negative. Well, where is negative 3 comma pi over 4? About here. I'm way off. Negative 3 pi over 4 is not the same as this. I'm way off. But how do I get over here? Just add pi. You guys were telling me add 2 pi. If I add 2 pi, I go past it. I'm right back here. I just want to add what? Pi. So, when you take the radius and you change it to the opposite, negative 3, just add pi. Watch. And pi is that. So what's the answer going to be? Negative 3 comma 5 fourths pi. Look, does that make sense that that would be the answer? Left 3 and go where? 5 fourths pi, which is 1 pi and a fourth more. It does make sense if you look and think about it. Okay, now wait a minute. How do you get to the next answer?
There's another pi?
Well, okay, remember how it was right here, so I added pi? If you add 1 more pi, I'm back to here. You want to add another pi, don't you? So watch. For me to graph negative 3 pi over 4, I'm here. Add pi, I get to here. That's the answer. But then I'd have to add another 2 pi onto it to get to here. So really, the first answer is add pi. The second answer is add 3 pi. The third answer is 5 pi. What? Odd pies. There you go. That's all it is. So here's what they want you to know. If you switch the radius to the opposite, then take your angle and add only pi n. But here's the deal. This time n has to be an odd integer. Has to be an odd integer. Because if you added 2 pi, you would get a circle and you would not be on that same point. Now I'll be honest, all that talk might have confused you. I think if you just make a picture and you go, oh my gosh, all it is just over 5 fourths pi, why is he telling me to do all this stuff? I'm only telling you this because I want you to understand the formula, how I get around and around and around back on that same point. But really, most of you guys can just do these things in your head. I know you can. I think you can. Okay, I'm done with that. That's just graphing and giving me the polar points, polar coordinates that give me the same point. Now, here's what I want you to do. I want you to do this. Convert from what to what? Polar coordinates over to what? Rectangular. Now, if you don't even know what polar is or rectangular, we're in trouble. So what's rectangular coordinates?
XY.
XY. And XY would be like this. X-axis, Y-axis. Polar coordinates are R theta. R theta is like this. The pole with a whole bunch of what? Circles around it. That's what polar is. Okay, so how do we go back and forth? Watch. Okay, they're making a blanket statement to you. You won't understand this unless you just go back to chapter 4 with me. Here's chapter 4. In chapter 4 we said, take a right triangle, place it where we have the origin as one of the vertices of the triangle. We called this theta, we called this x, this y, and we called this the radius of our circle. So, tell me this. Do you remember that we said cosine of theta is x over r? Adjacent over hypotenuse, x over r, right? So if cosine of theta is x over r, here's what we can say. We can say that x equals r times cosine of theta. How come? How come I can say this is really this?
Because you just times it by r on both sides.
I'm timesing it by r on both sides. Cross out the r, times it by r. Yeah, x equals r times cosine of theta. That's it. Well, then they say, well, remember in chapter 4 when you said sine of theta is just y over r? So then we can say that y equals what? This is wrong, by the way. Y equals what? Cross out the r's. R sine of theta. There. That is going to help you convert from polar to rectangular. If you can remember this, you're going to be sitting pretty. Get this in your head, get this in your head, and this is where it came from. Okay? Here we go. Take this point, which is polar, by the way, and take polar and convert it over to rectangular. So here's r, here's theta, convert it to x comma y. And by the way, you might want to just kind of know where you're at. Where am I? I'm at 3, and then I'm at 2/3 pi. What's 2/3 pi? It's actually about 120, isn't it? Okay, so here's where I'm at, and you guys should know this. In rectangular coordinates, the x value is what? I'm going backwards. Negative. Your x value better be negative. Your y value better be what? Positive. Okay, here we go. What is x? What is y? Go back to the previous slide. What did we say x was?
Can't you use like the special right
I
triangle?
will, but I want you to tell me the formula. What's the formula?
X equals R cos times
R times cosine of theta. This one's r times sine of theta. Are you with me? So then I'm thinking, oh, my r value is 3. My angle is 2/3 pi. Then I'll do this one. So I'm just taking the polar coordinates, sticking them into the formula, and I'm going to work it out. Now, Christian, you're trying to tell me, isn't this just a special triangle? He's right, it is. What special triangle is it from here to here? That is a 60. That is a 30. That is 2. This is -1. And this is, that's wrong. This is what? Square root of 3. Okay. All right. Here we go. Finish it. 3 times, what's cosine of 2/3 pi? This over this. -1 1/2. Comma, this will be the x value, by the way. Comma what? 3 times what? Square root of 3 over 2. So if you did all that multiplying, you'd end up with that, comma, that. So what I'm trying to tell you is the point 3 comma 2/3 pi is the same thing as this in rectangular. This says left 1.5, this says up, up, up. I don't know what that says. I'd have to punch that in. But this says left 1.5, up something. And that would get me right here. Right there. Okay?
It's 2.6.
Is that what it is? So this says go left 1.5, up 2.6, and I'm right on that point. They're the same, that gets you to the same spot. Okay? Do that one, and why does it say approximate? Well, yeah, because it's not one of your special triangles. So just do it. See what you get. Okay, I just did exactly what I did last time. This time, I just threw in the 95. Because I don't have any special triangle to look at. So you tell me, what does this one say? How far should I go right or left? What's my x coordinate? 0.17. What's my y coordinate?
Negative 1.99.
Really?
That's what I got.
Okay. I for some reason, don't remember that answer. Hang on. I'm sure you're right, Corey. My memory's going. You're right. My fault. All right. There it is. Are you okay with that? Does anybody out there ever say to themselves, is that right? Do you ever wonder, is this right? Can you guys somehow kind of know that, where is this point located? Where is that? Where do we find negative 2 comma 95? When it comes to polar coordinates, negative 2 means go where? Left 2. Then where? 95. That's 90. There's 95. In rectangular coordinates, does it look like I went over and down 0.17 this way and down 0.95? Does that look about right? Oh, I didn't mean to put 0.95. I'm sorry. I meant to put what? Yeah, negative 1.99. Does it look like that is about what it should be? See, it does to me, and I like to know, yeah, the calculator tells me that answer, but I like to know why that's the answer, don't you? I don't want to just accept numbers and say, oh yeah, good. I want to know why it's good, okay? Maddie, can I go on? Okay. All right, let's convert from what to what this time? Rectangular to what? Polar. They tell you right off, here, just use those. Well, why should I use those? Go back to that triangle. Look at the triangle. Here's R, here's Y, here's X, here's theta. Now, if you want an angle, well then, how do we get angles? There's Y, there's X. If I take y over x, that's just tangent. Tangent of theta equals y over x. That's what they wrote for you. So if you ever want the angle, how do you get the angle? Guys, tangent of this is this one. How do you get the angle? Isn't it just this? Right? And then this, hang on, I just want to get this in your head. This is the Pythagorean theorem to get r. Oh, well then r is going to be r equals square root of this. Those two things I would write down before you leave. And then you use them to convert. I will, hey, if this throws you for a loop, I'll catch you up tomorrow. Okay?
Peter, we tried this stuff.
This stuff.
What do you need?
Yeah, if the worksheets are done, I'll take them. If they're not done, well then I guess you get some more work to do. Anybody done? 1, 2, 3 maybe, 4, 5? There you go.
So I'm leaving again for
Oh, you're not
nationals. We leave that Friday at noon,
Okay.
but my English teacher, I have English 4th hour, and she said if I finish the assignment ahead of time, I can come to your 4th hour pre-calc
Oh,
class, if that's okay with you.
yeah, that's fine. And then you'll just take that
I'll
class.
just take the quiz that day, and then I'll be gone on Monday, Tuesday, Wednesday, Thursday.
Okay, let's see there. Oh, wait a minute. Keely, Colton. What else should we do? Yeah, so then you're gone this day, this day, this day. And that day?
Yeah,
Hopefully.
yeah,
So this is 6-5. So we're going back to chapter 6.
okay.
6-5, 6-5. Review. Oh, you know what? This next week, that's the week we'll be taking the junior math portion of that test.
Okay.
So then I lose Thursday.
Oh.
I won't. Gosh, no, you guys. I lose you guys. Those 2 days.
But I won't be here.
Yeah, but I mean, I'm saying.
Yeah.
With your class, I can't really do much. So
Okay.
you're really only missing those 2 days.
Okay.
Okay. All right.
I'll choose the bathroom.
Yeah. Go ahead. Go ahead. So then, 6-5 is what you missed.
Okay.
And I don't know how I'm going to treat that whole thing. Because
Alright.
I get period 4 and I get period 5. And then I just don't get you guys. So,
I did all of it, but I didn't have enough time to finish this back. But other than that, I finished it off.
Yep.
You're welcome.
thank you.
No problem.
Morning.
Yeah, I do.
Okay. So, our next time. No. As long as it takes you the right much time. Okay. Are you ready?
I suppose.
Charge your battery up.
Um,
You go drink a pop.
Oh, me?
You all fired up?
Yeah, I'm good to
You're
go.
good to go. Okay.
Yeah, I just needed a break.
Okay. I'm gonna take care of her and Cole. Kaylee, you did start? Okay. So, okay. Yeah. This, we'll start here.
Okay.
There's the 5th period.
Okay.
There is 6th period.
Okay.
And I will tell you how to put those in the book in just a second. There is 4th period.
Oh, okay.
And you don't need this. Okay. You need this. Okay. And so it must be here. Yes. Oh, it's Caleb. Oh, there's Colton. Slide it over there. Okay. Alright, he's coming back. Ryan's done. Jamie's coming back. Okay. Are you okay?
Kind of.
Do you want to ask me anything?
I just like, I really don't remember how
Oh, you can't look at the test. You gotta just ask me a question.
It's just like the parabola section. I have really got.
Okay.
Like everything else, I feel like I'm okay at. It's just like,
When it comes to parabolas, you just need to know the p-value. Now the p-value is from the vertex to the focus. Okay, now, if the vertex is here and we go up, p is positive. Down, negative. Now if it goes this way, if you go right, this is right, left, negative. From where? Vertex to focus, vertex to focus. Okay? Once you know the p-value, you stick it into the equation. Remember how it says x squared or x minus h squared
yeah, I was just right.
equals
Yeah.
4py. Well, if p is 2, put 2 in for p, 4p. 4 times 2 is 8y. Is the answer. That would be the equation. You got to know that when a parabola goes this way and this way, it's x squared. But when parabolas go this way, it's y squared. This looks like a hyperbola. Right? To get p, if you visually can see it, oh, it's 2 that way, oh, it's 2 that way. That's easy. If you can't see the focus, then there's ways to get p. You can be given a point on the parabola. Here. If they give you a point on the parabola, they're giving you x, y. Stick x into the equation, stick y into the equation, solve for p. Remember, you gotta find p. Okay, the other thing you could run into is they actually give you the equation. They say, here's the equation, graph the parabola. Well, when they do that, you know how it says x squared equals, and then it says 12p, or sorry, 12x, or 12y. The 12 came from 4p. So 4p must have given me 12, so then p must be, yep, then you got p. And then you can draw the parabola. Oh, here's the vertex, 1, 2, 3, here's the focus. Okay. There's a lot to it, but I can't sit here and teach you it right before you take a test, okay? So, hopefully that helps you.
It does.
A little bit? Okay. There you go, ma'am. Okay, Colton, you're good? You know what you're doing?
I think so.
Okay. All right.
Yeah.
Okay. Now,
What's that?
you got a calculator?
Yeah.
Now, here's what we're gonna do. Oh, I already did this.
Yeah, you put them all in.
Okay, forgot about this. Okay, so 35. This is out of 66, so go ahead and hit that right now. Okay, do me a favor.
Yep.
Just always, oh shoot. Just round correctly. I guess 53 or 54, 53.
Okay, so there's some 44 to 53, 45.
Yeah, okay. So just round normal. I was gonna have you do something to help him, but that is 53. So he gets 53, but hang on. If you ever see a 5 up here,
Yes.
that's 5 bonus points. So we're gonna give him 58. But he didn't get any bonus points, so he gets a 53.
Okay, so.
You get what I said? If they have a little tiny number up in the corner, you would just add 5.
65 divided by 66. So then
Yep.
add that to the percent.
Yes, so that's 98. Right?
Yeah, so what are we?
Yeah. Okay, you okay now?
Yeah.
That's all it is. I'm waiting on Jamie, she's back there. And then, two more who are, Pachet's done, I'll get Pachet's done.
Okay.
Tierney's coming. I just want to see who's here. Kaylee's here. You know, Kayla, if I look her up, she didn't talk to me, so I'm thinking she might come back. Can I send you the finder?
Yeah.
You're right at the end of the hour.
Yeah.
Okay. There you go. Okay. Then, as soon as you're done with that, here's the math model.
Okay.
I'll just teach you how to do this now.
Mhm.
Then you can kind of fly. Okay. All right, did about 5 of these.
Okay.
So let's just take a quick peek. Okay, first of all, it's out of 25. Even though it's only 25.
Okay.
So they get all wrong.
And so they'll, okay.
Yep, yep. Just put their name on it, okay?
Oh, okay.
Now,
So no name, one, just.
there you go. So yeah, they don't put their name, they lose everything. All right, this, the only time I ever gave them half a point, it's always, if it's not right, it's not wrong.
Okay.
But I'll show you when I did give them a half. Oh, here's one. It's negative 127. That's, they put 1 over 3 cubed, which is 127. But they forgot the negative. So I took half one.
Okay.
This, they just use their calculator to give me that.
Okay, so you
And I'm
want
not-
the fraction.
I want the fraction. They've never been told to do that.
Okay.
This person did it. Personally, because he does everything by calculator. All right. So, I mean, to me, like 8 and 6,
Mhm.
that's 6. I mean, it's just wrong.
Yeah.
Okay. So it's really simple. Just wrong, 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 wrong.
Okay.
Negative, I gave him half because that was so close.
Right.
Okay. I'm just looking for the halves. Here's a half. 24 over 36 is 2/3. So 2/3. I kind of thought, well, the hardest part is the rules of exponents, reducing.
Okay.
Okay. Oh, there's a half. Oh, this kid got lucky because I actually really worked hard. This kid subtracted 24, got negative 6. It should have been -6.
Okay.
Knew to take the negative exponent and put it on the bottom. So to me, this
Oh, okay.
really knows what they're doing. They just
Right.
made a silly mistake. Whether you caught that or not, I don't know. If you don't catch something like that,
Right.
then they'll talk to me tomorrow. They'll say, "Well, I forgot." You know.
Right.
They'll if they argue their point, I'll give it to them. Okay. So here's half. Oh, again, forgot the negative,
Okay.
right? Okay. So you get in the negative got them and reducing the fraction got them.
Okay.
That was about it. Yeah, that's all I graded.
Sounds good.
So it's pretty straightforward.
Right.
Okay. Good?
Mhm.
All right. There's period 1. You got period 2 over there.
Sounds good.
Okay. Out of what?
That one? 25?
Good.